All right, the next type of factoring is factoring a difference of squares. Like I said before, this is the easiest type of factoring. So when it comes to factoring a difference of squares, we're looking for a difference. Difference means subtract. We're looking for subtraction. All right? We're also looking for an expression with only two terms. Two terms. And we're looking for two perfect squares. The squares mean perfect squares. All right, so this is a two-term expression. Now, we're still going to factor it into two sets of parentheses. The reason, though, that there is no middle term is because it has been canceled out through the FOIL method. The FOIL method has basically canceled it out. Now, how do we factor a difference of two squares? Well, first of all, we have to check to see if we are dealing with a difference. Is this a difference? Yes. And then, do we have two perfect squares? X squared. Can you take the square root of it? Yes, you get X. Can you take the square root of 4? Yes, it's 2. So the answer is yes. So here's how we do it. We do X and X. We do plus and minus, because that's the only way we can get a negative, right? That's right. And then we do 2 and 2. We just took the square root of X and the square root of 4, and we plugged those values in with plus and minus. That's all there is to it. So if we look at number 22, is it a difference of two squares? Yes. Y and Y plus and minus 9 and 9. So easy. All right, look at 23. Before you start factoring, ask yourself, is it a difference of squares? It is a difference. Is 9 a perfect square? Is X squared a perfect square? Yes. Is 25 a perfect square? Is Y to the 4th a perfect square? Yes. So it is. So we break it down into 3x and 3x plus minus 5y squared and 5y squared. And we're done. You're just taking the square root of each of those perfect squares. Okay, look at 24. Is it a difference? Yes. Is m squared n squared a perfect square? Yes, because anytime you have an even exponent, that expression is a perfect square. That variable expression is a perfect square. Is 49 a perfect square? Yes, 7 times 7. So m n plus minus 7, 7. It really can't be any easier. All right, 25. Okay, now, what we have not done in these other problems that we failed to do, and that's my fault, was we did not check for a GCF. But you must check for a GCF. So, do 72 and 2 have a GCF? Yes, it's a 2. So I'm going to factor out the 2. That leaves 36r to the 6th minus s squared. Now, is what's left in parentheses a difference of two squares? Is 36 a perfect square? Yes. Is 6 a perfect square? R to the 6th, that is. Yes. Is s squared a perfect square? Yes. Yes. So, 6r to the 3rd, 6r to the 3rd. You just cut it in half when you take the square root of an even exponent. Plus minus s and s. And we're done.
Wait, okay. Alright, I got it.
Got it? Alright, look at number 26. Okay, check for a GCF. Is there a GCF between 2 and 32? 2. Is there a GCF between a squared and a to the 4th? Yes, what is it? A squared, remember the lowest exponent. Is there a GCF between b and b? Yes, b, right? So, in parentheses, we will be left with 1 minus 16a squared. We divided it out. So 2a squared b divided by 2a squared b is 1. And then negative 32a to the 4th b divided by 2a squared b is 16, negative 16a squared. Alright, now, is 1 minus 16a squared a difference of two squares? Nod your head yes. Because it is. So Donovan, what we're going to do is, we're going to break up the 1 into 1 and 1. We're going to break up the negative into positive and negative. And then the square root of 16 is 4, and the square root of a squared is a. So 4a and 4a. And we're done. Alright, flip the page. Go again to the back of homework 1. Okay, I'm going to stop the video now, and we're going to practice a couple of these. Okay, Bradley, talk us through it.
You take out 5 of each of them, so it'll be 5 parentheses 4c squared minus 9d squared. And then it will be 5 parentheses 2c minus 3 and then d, and then 2c plus 3d.
Excellent. That's it. All right, Michael, what about 16?
16?
Yep.
16 will be mine.
3m plus 7. And then parentheses 3m minus
5 divided by
Good.
20.
All right, Kel, what about 15?
Okay. Was 5 a minus 5.
Very good.
I want that one.
Outstanding. All right, now let's get some more practice.